And the second part of the Chapter 3 notes, we're going to look at the differences between temperature and heat and talk about kind of a definition of energy and how we can use a formula to calculate energy changes. So energy is just the capacity to do work. There's a lot of forms of energy. So the types of energy that you may have heard of, we've got kinetic energy, potential energy, electrical energy, light energy, thermal energy, sound is energy. All of these we'll take a look at throughout the semester, but we're really going to focus on thermal energy for this section and for these types of calculations that we're going to be working on. Okay, so heat is just the flow of energy due to a temperature difference. So there's changes in the amount of energy of substances based on this temperature gradient. So if you've got a hot stovetop and you touch your hand to it, you immediately feel that heat and feel the effects of the heat and that flow of energy because there's such a huge difference from the temperature of the hot stovetop and your hand. Okay, chemical reactions can produce heat. Some of them, though, absorb heat. So whenever you have the ice packs that you may break, and so they feel cold because they're absorbing heat from your skin. And so those are endothermic reactions because they're absorbing heat. Exothermic reactions, like the hot hands packs that you may, you kind of shake those around and they give off heat and they warm up your hands because they're exothermic reactions going on within that little packet. Okay, so when we calculate energy change, all we're really doing is looking at the change in the motion of the molecules or the kinetic energy of the molecules. So as the motion increases, the temperature is going to raise also. The amount of energy required to raise the temperature of 1 gram of water 1 Celsius degree is called a calorie. The unit of energy for the SI is called the joule. And so 1 calorie is equal to 4.184 joules. So you'll use that calculation quite a bit, and we'll see that number again. All right, so we've got our first practice problem. This is practice problem number 1. If we wanted to express 60.1 calories of energy in units of joules. So this is basically just a conversion problem. Okay, practice problem number 2. How many calories of energy correspond to 28.4 joules? So again, this is a conversion problem. Okay, practice problem number 3. Determine the amount of energy in heat in joules required to raise the temperature of 7.40 grams of water from 29 degrees Celsius to 46 degrees Celsius. So there's a couple of things we need to do with this one. We know that we have 7.4 grams of water, and we know we've got this change in temperature. So the fastest way to go about this is, if we remember our definition of a calorie, it's the amount of energy required to raise 1 gram of water 1 degree Celsius. So if we need to figure out the temperature change, so we'll take 46 minus 29, and we also need to figure out how many grams of water we're raising that temperature change. Okay, in a similar problem, practice problem number 4, calculate the joules of energy required to heat 454 grams of water from 5.4 degrees Celsius to 98.6 degrees Celsius. All right, so we've seen that the energy required to change the temperature of a substance depends on, one, the amount of substance being heated. So it takes more energy to raise a greater amount of substance than just 1 gram. Okay, and we've also seen that the temperature change, the amount of temperature change is also important to the amount of energy required. Okay, but there's one more important factor about the substance, because we've only talked about water so far. Okay, so different substances respond differently to being heated. We know that heating 1 gram of water, 1 degree Celsius, takes 4.184 joules of energy. But if we apply 4.184 joules of energy to gold, the temperature increases almost 32 degrees. So the temperature change is much greater with this metal than if we applied the same amount of energy to water. Okay, so the amount of energy required to change the temperature of 1 gram of substance by 1 degree Celsius is the specific heat capacity, or the specific heat of the substance. Okay, so we've got another practice problem here. What quantity of energy is required to heat a piece of iron weighing 1.3 grams from 25 degrees Celsius to 46 degrees Celsius? Okay, so there's a formula that we need for this to be able to make this calculation. Okay, the same with this one. We've got 5.63 grams of sample of gold. It's heated from 21 degrees to 32 degrees. We need to figure out how much energy for joules and calories is required. So to do these problems, we need to use our formula here to calculate the change in heat, or the amount of energy required. Okay, so we've got some variables here. Our Q represents the energy. That's what we're going to be solving for. Specific heat is specific to the substance we are investigating or doing the calculation for. M is the mass of the sample in grams, and then delta T is the change in temperature in Celsius degrees. So we may need to calculate that sometimes, and to find the delta T, we just take the final temperature minus the initial temperature to see the change in the temperature that we're using for the calculation. Okay, we've got a couple more practice problems. 1.6 gram sample of metal that has the appearance of gold requires 5.8 joules of energy to change its temperature from 23 degrees Celsius to 41 degrees Celsius. Is the metal pure gold? Okay, so this one is set up a little bit differently. We're given the mass, we're given Q, or the energy, and we're given the temperature change. So what we need to do is rearrange that formula, solve for the specific heat, and then see if it matches the specific heat for gold. Okay, a 2.8 gram sample of pure metal requires 10.1 joules of energy to change its temperature from 21 degrees to 36 degrees Celsius. What is the metal? Okay, so this problem is set up similar to the last one, and you can compare the specific heat from your calculation. To the specific heats listed in this table. There's also a table in your book that you guys can take a look at when you're working on these problems.